Today's lesson is going to be about linear inequalities. We have spent a lot of time learning about linear equations, and now we're going to move forward and talk about linear inequalities. The good news is that almost everything we know about linear equations is the same as linear inequalities. Look at the two graphs below. One of these, the first one, is a linear inequality, and one is a linear equation, the second one. List some similarities and differences between the two. Hopefully you notice the similarities that the lines are the same. They both start at the y-intercept of 4 and they rise 1 and go over 2. The lines look exactly the same. However, some of the differences would be in the linear inequality, the line is dashed versus a solid line in the equation, and we have an area shaded in the inequality versus the equation. So the two big differences between the graphs are the shading and that the line is dashed. Similar to graphing inequalities on the number line, there are two types of boundary lines we can use to graph inequalities. And think about when we graphed inequalities on the number line. Our two different types were an open circle and a closed circle. Well, now we're going to have two different types of lines to have the same idea as the open and closed circle. Also, we need to shade with the inequalities because there's a range of answers possible, just like inequalities on the number line. When we have an answer to an inequality on the number line, remember it's x is greater than 7. So that means 7 is not a possibility, but 7.1 is, 7.2 is, 8, 10, 15. It's the same idea with linear inequalities. We're going to have a range of answers. It won't be one specific one. Now, there are two types of boundary lines. A boundary line exists to show the border between solutions of the inequalities and points which are not solutions, just like we use the open and closed circles. The first boundary line is a dashed line. We use the dashed line when the boundary line does not include solutions of the inequality. So like our open circle, when x is less than 7, 7 is not a solution. So we use the dotted line when the line is not a solution, or when we have less than or greater than symbols. The second type of boundary line is a solid line, just like an equation. We use a solid line when the boundary line does include solutions of the inequalities. So for example, x is greater than or equal to 8, well, 8 is a potential solution. So we have the symbols of less than or equal to or greater than or equal to. Now, to graph linear inequalities is very similar to graphing linear equations. We graph a linear inequality just like we would graph a linear equation using either a dashed or solid line. So, we have the equation y, or the inequality, y is less than 2x minus 1. Well, if we were going to graph this as an equation, we would start at the y-intercept of negative 1. We would go up 2 over 1. You can see, if you look closely, there are little red dots to help where I went up 2 over 1 to graph my line. Now, it is a less than symbol, which means it's a dashed line. So you're seeing that the line is not solid, but dashed because of this symbol. Now, the shading part is a little more difficult. We're going to look at where are the y values. So when we think about shading, think about where are the y values going to be less than to the right side or left side of the line. So look at the graph. Our equation is y is less than 2x minus 1. Where are the y's smaller? Hopefully you said to the right side is where the y values are smaller, or where the y values are primarily negative. Above the line, we have positive y values. They're getting greater. Below the line, the y values are smaller. So the right side is where the y values are going to be less than. If that doesn't make sense, you can also test a point on both sides of the line, see which point is the solution of the inequality, and that'll tell you which side to shade. So we can start with the point negative 2, 1. Negative 2, 1 would be right here on this side of the line. I plug it into my inequality. The x value is negative 2, the y value is 1. And I solve, and I get 1 is less than negative 5. Well, that's not true, so I know that is not a solution to my inequality. Let's pick one on the other side of the line. 4, -1 would be down here, so it would be on the right side of the line. Plug in my x value of 4 and my y value of -1 and multiply and solve, and I get -1 is less than 7. Well, that is true, so that side is the solution. So we want to graph the side where the solutions are, or we want to shade where the solutions will be. Let's look at a few more examples. To begin this one, we're going to start by hitting the y-intercept at 6 and then going down 3 to the right 4, and you can again see how these points are graphed. Now y is less than or equal to this equation, so the y's are smaller underneath the equation. Or again, we could test 2 points, but I want to shade the bottom where the y's are less than. In the second example, we're going to start at -1. We're going to go up 4, over 1, and I graphed a couple points to help me get my line. It is a dashed line because it is greater than, so it does not include the solutions. And we're going to think about shading. Well, where are the y's bigger? The y's are bigger on the left side, 2, 4, 6, 8, 10. So I'm going to shade the left side of the graph, and that means that all of this area that's shaded, or this gray area, is going to be a solution. So any point I pick in this gray area is a solution to my inequality. The same thing in this first graph, anything I pick in this area is a solution, as well as any point on the line. So we have lots of potential solutions. It's your turn. Graph the inequalities. Pause the video and try this. The first one, you should have used a dotted line, and you would have shaded below the line because y is less than. So all the potential solutions are at the bottom of the graph. And the second one, y is greater than or equal to, so I needed to use a solid line, and I wanted to shade to the right because these are where the y values are bigger. So anything in this gray-blue area would be a solution. So I could pick the point 4, 6 and plug it in, and it would be a solution to my inequality. That's all we have for today. So if you have questions, please bring them to class. Have a great night.